Now in this video we are going to be looking at normal equation of regression analysis. If you are looking for normal equation, you want to derive normal equation of regression analysis, what you just have to do now is just to get the value of to get your deviation. How do you get your deviation? That is, you need to look at the observed value and the estimated value. You look at what I have on the board here. Look at what I have on the board here. And now this is the observed value that I've gathered. This is the observed value. And from this observed value, I can make a line. I can just make a line. Okay, let me make a line like this. You see this line I've made, that is my regression line. That's my regression line. That's my regression line. So I can write as this estimated, it's also estimated value. That is the estimated value. And my estimated value, I can write it like this. I put the sign of estimation here. This sign is estimation. And now, for instance, if I like what I have here now, you can see that there is a point here, there is a point here. This point is on the estimated, and this one is of that of observed. So the difference between this point and this point now is what we call deviation. It's what we call deviation. And now, when you say deviation, it means two things are involved. You have estimated and observed, and that is what we have here. Estimated and estimated equals observed minus deviation equals observed point here minus estimated. That is, so this is what I'm going to use to get our normal equation. Now quickly, now because of time, let's open now. This is our deviation. We can write it as our observed y minus, so I write the value of the estimated here. I put it in brackets. Put it in brackets, I'm going to be having b naught, put the sign b1x. Yes, I put the sign also here. Then I can open the bracket here using this sign, minus times plus. So I write again minus times plus, it's going to give me minus. Then I put the sign back, minus times plus again, minus, I put the sign back. Now, having understood this, at this point now, so what am I going to do at this point? You know, we are trying to derive a normal equation of regression analysis. Now, what we just have to do is to square. We need to square and then sum the deviation. If we look at the deviation here, why are we squaring? We are squaring because we don't want to have 0 as the answer between the observed and the deviation. That is, when we say observed minus deviation, we don't want to have 0. So we want to make the value bigger. And you know, when you square a value, like you square 2, it's going to give you 4. When you square a value, it's going to give you a bigger one. So that is what we are trying to do. We don't want it to be 0 as our final answer. We don't want 0 as our final answer. So when we square now, we square this deviation. When we square this deviation, we sum and square the deviation. So when we that is what we have done here. And when we sum it now, it needs to reflect here in this equation. Then I put it here back. Then I put my y minus b naught. Then I bracket it. The square will also reflect here. Now, having done this now, so what you just have to do is just to minimize. So, you know, when you want to minimize, that is calculus, we need to differentiate that function with respect to any of the determinants. So we will be taking b naught first. If you don't know how to do the differentiation, please go back to our video. You consult some materials on differentiation. Here we are going to use function of function because of the power we have here. Now, if you want to differentiate now, don't forget that when you are differentiating, you differentiate with respect to 0. We are trying to minimize, so we take the least square. We take the least square. Now, we've squared all the deviations, but we are taking the least out of all the deviation. And when you are taking the least, it means we are minimizing it. That is where the name is, you know, is just least square method, because we are taking the least of all the square we need. Now, so taking the least now, we need to minimize it. That is, when we are minimizing it, we are going to say this particular function here, change in deviation with respect to change in b naught, then that's going to be equal 0. So having gotten this now, then we need to differentiate. If you differentiate this now, if you differentiate, we don't use you use called derivative. So if you use called derivative, then we'll be having 2. These 2 will come here, summation bracket again. Then you write the whole of this here. You write it this way. So you don't write the square back. Now the n minus 1 offshore this. So we have 2 here. Then you now differentiate the one we have differentiated with respect. This is b naught. So if you differentiate minus b naught here, you're going to have times minus 1. So everything will equal 0 because equal 0 is there. Now, having done this, now we can multiply this. Minus 1 times 2 here will give us minus 2. minus 2. So when you have minus 2, you have summation, you have y minus b naught minus b1 x, put the sign, everything equals 0. To offshore this minus 2, you divide both sides by minus 2. If you divide both sides by minus 2, so the minus 2 will go away. The minus, so the minus 2 will move away from here. The minus 2 will move away from here. So we are going to have 0 left. So that's what we have done to cancel out that minus 2. Now, we have this left. So we can just use this to open the bracket. We just have a summation y minus, this is going to be here now because this constant value here. So this is constant value here. Then that is the intercept. It's going to be here. Then minus summation times this is going to give us b1 summation x equals 0. So we can equate this. We can now make this subject of the formula now. Solution y equals, this will give us plus, right? That's going to give us plus. Please check very well. Is it going to give us plus? Oh, since we have n here, we don't need to repeat the summation again. We don't need to repeat summation again. So we are going to have, just have our b plus b, and minus when it comes to this side to the right, it becomes plus. Then this one will come to this side, will become plus b summation x. That's the first equation we need. That's the first equation, equation 1. Let's quickly do equation 2 because of time. Equation 2. So if you are finding our equation 2, we will now differentiate with respect to b1 now. So this is our value here. We are using this value, don't forget. We are using this value. We are using this value. Summation, brackets, y minus b naught, put the sign. Oh, let me write, please. Let me write. Using summation, yes, y b naught, put the sign, that's what we are doing. Now, then we differentiate now with respect to b1. Differentiate with respect to b1, we equate to 0. So when we equate to 0, then the next thing we do, we take the square is here, of course. So when we take the derivative now with respect to b1, so we are going to be having, the 2 will come like other before, 2 will come here. So when these 2 come here, we have brackets. We write the whole of this function back, put the sign, don't forget. We have it back. Now, we now differentiate respect to b1. That will be times minus x. So don't forget it's going to be equals 0. Now, this minus times minus 2 minus x here. Okay, let's make it this minus this minus now. Minus times 2. Minus times 2 will give us minus 2. Minus 2, then x will give us minus 2x. Bracket. The equation is still there, sorry. Minus x times 2 will give us minus 2x. Then put the sum back, open the bracket here, then write this one, y minus b naught minus b1x bracket equals 0. Now, we want to eliminate minus 2 as we eliminated the 2 here. So, minus 2, minus 2. This will go away, this will go away. So, we're having left now x summation y minus b naught minus b1x equals, okay, close the bracket, equals 0. Now, we can say x now. When we say x times y, that will be summation x times y will give us summation xy. Then summation x times this will give us minus summation. Look at that equation very well. When you say that will be summation, this will be summation x summation or summation x times this will give you summation xy. Then for this one we give you summation x times b will give us b. We write the b first, summation x. Then the same thing here, plus times minus, of course, minus. Then this will give us summation, right? B. Then summation x now times summation x will give us summation x squared. Please, do you understand it? Make it equal 0. So this one, we make this subject of the formula now. We are going to be having xy. So all of this will go to the other side. We're going to be having b summation x. This will be b summation x squared. So this will be equation 2. Now I can bring the equation 1 together now, which is summation y equals bn plus b1 summation x. Then the equation 2, summation xy equals b summation x plus b summation x squared. That's my equation 2. That is my normal equation. From here now, we can now go and derive least square estimate. That will be in the next video. Least square estimate. This, if you want to get it now, I must tell you the truth. You need to try it from the beginning like 4 or 5 times. By the time you try it 4 or 5 times on your own, if you make mistake, cancel it, start all over. You make mistake, cancel it, start all over. You will definitely get it before you write your exam. Please subscribe and get more of our video.